Hello and welcome to this video on increasing and decreasing functions. A function can be described as increasing and or decreasing in certain intervals. As these terms suggest, a function is increasing when the graph is going upwards as we move from left to right, and a function is decreasing when the graph is going downwards as we move from left to right. As we can see in the diagram, it's increasing in the first section on the left, and it's decreasing in the middle, and it's increasing as it tends off to infinity on the right hand side. Formally, an increasing function is one whose gradient is always at least 0, i.e. f-x is greater than or equal to 0 for all x, and a decreasing function is one whose gradient is always at most 0, i.e. f-x is less than or equal to 0 for all x. A function would be strictly increasing if f-x is greater than 0 for all x, i.e. it's not allowed to go horizontal and be 0 at any point. An example of that would be f of x equals x cubed plus x. And of course we could also have a strictly decreasing function if f-x is less than 0 for all x. We have the same diagram now but with coordinates. So we have a point where the gradient is 0 at 2, 3, and another point where the gradient is 0 at 4, -1. So the function shown is increasing for x is less than or equal to 2. It's then decreasing for 2 is less than or equal to x is less than or equal to 4. And then it's increasing again for x is greater than or equal to 4. We could also write that f of x is decreasing in the interval 2, 4, where a, b, i.e. 2, 4, represents all the real numbers between a and b inclusive, i.e. the interval a, b is given by x's between a and b using our inequality notation. Okay, we're going to finish with a couple of worked examples. So the first one says, show that the function f of x equals x cubed plus 6x squared plus 21x plus 2 is increasing for all real values of x. So an increasing function is one where f-x is greater or equal to 0. So we've got to show that this function has f-x is greater or equal to 0. So the first thing I've done is to differentiate, which gives me 3x squared plus 12x plus 21. And since that's quadratic, we can complete the square to show that the minimum value is whatever it is. So completing the square, you can see what I've done there. We end up with 3 brackets x plus 2 squared plus 9. And to make a formal statement of that, since x plus 2 squared is always going to be greater or equal to 0, since it's a squared term, that means that 3 brackets x plus 2 squared plus 9 is also going to be greater or equal to 0 for all real x. In fact, the minimum value is going to be 9, and hence f of x is an increasing function for all real x. Now, in this example, we got a quadratic when we differentiated, and if you look at the note at the bottom left, it says to show a quadratic is always positive. You can complete the square and indicate the square term is always at least 0, but that is only going to work for quadratic expressions because we can't complete the square for cubics and other examples. And then for our second worked example, we're asked to find the interval on which the function f of x equals x cubed plus 3x squared minus 9x is decreasing. So we differentiate it and put it less than or equal to 0. The differential is 3x squared plus 6x minus 9. We put that less than or equal to 0. We can divide everything by 3 and factorize it. And the critical values are -3 and 1. They are the values where the expression equals 0. So if we want the expression to be less than or equal to 0, that's between those values, so between -3 and 1. So f of x is decreasing in the interval -3 to 1. Thank you very much.